Welcome, ladies and gentlemen. So what is it, the things that you're going to need to know to be able to graph linear inequalities? Well, the first thing when graphing linear inequalities, they're just like graphing linear equations. So the main important thing when graphing linear equations is understanding and identifying the slope and the y-intercept. Most important thing, and I'll get to this in y-intercept, but remember, or into the next one, but remember the y-intercept is where the graph crosses the the y-axis. So it's a point. It is a coordinate point where, most importantly, that coordinate point is 0, b, where the x value is always going to be 0, and b represents that value where the graph crosses the y-axis, which will take more shape once we kind of talk about the y-intercept form. Really, it's 0, y. It's the y value on where it crosses on the x-axis. But a lot of times we use b because we're talking about slope-intercept form. The next thing, slope, remember, is the ratio of change between any two points, where we're looking at the change in the y values between any two coordinates over the change in the x values between any two coordinates. A lot of times we talk about that as like rise over run, but basically it's just the change in how you're moving from any 2 points on a line, how you're changing vertically and horizontally. So the next thing to graph in linear inequalities, you have to know how to graph in slope-intercept form. Y equals mx plus b, where b, that comes from that b. All right, that's what I was talking about when I'm going to b. And m represents our slope. All right, so when we're graphing in slope-intercept form, remember we plot the y-intercept first, and then we use the slope as our rise over run to be able to find the next point on the line. The next thing is a graph in standard form. A lot of times in standard form we have ax plus by is equal to c. So sometimes we'll have equations that are in this format, and there's a couple different ways we learned how to do this. A, b, and c just represent real numbers. M and b represent the slope and the y-intercept. So if we have it in standard form, we can solve for y, and if we solve for y, then we'll know the values for m and b. All right, and then we could graph it that way. The other way to use this is using what we call our intercept method, where we plug 0 in for x. Or I'm sorry, let's do it this way. Yeah, let's plug 0 in for x and then solve for y. Well, if we put 0 in for x and solve for y, that's going to give us the y-intercept. And then if I plug 0 in for y and solve for x, that's going to give me the x-intercept. So I can plot the two intercepts, connect, and I'm good to go. The next thing is using the test points. You're going to need to know how to use test points, because we're going to use test points to determine where are we going to shade. Are we going to shade above the line or below the line? And so we're going to choose points that are not on the line to determine if they're true or false. If they're true, then we're going to shade, kind of represent that all the points, let's say I pick a point above the line, and it's true. That means all the points above the line are going to be true. And if it's false, that means all the points below the line. Test points also kind of gets into determining if your graph is a part of the solution or not. And more than likely, we like to look at that with inequality symbols, which I'll do in another video. But basically, if your inequality is less than or equal to or greater than or equal to, then your line is going to be solid because your graph will be a part of this, or the points on the graph will be a part of the solution. And if it's greater than or less than, then it will be false, and that means the points will not be a part of the solution, and we'll graph our linear equality as a dashed line. But there you go, ladies and gentlemen. That is basically everything that you're going to need to know to be able to graph linear inequalities. Thanks.